Right. Okay. Good evening, everyone of you. I think you can hear my voice, right? You can hear my voice, and the video is much clear, I hope. Right. So, welcome you all for the free seminar series, which is under the oscillation and waves topic. And today is the very first day that we are starting the oscillation waves topic. And I must tell you that the seminar series is totally free for you all. Today I'll be starting the new topic, that is the oscillation waves, your unit number 3. Starting from measurement, mechanics, oscillation waves, like that. There are 11 topics in your syllabus. Oscillation waves is your third topic. It is your third topic. So, Lamai, there are some units that you would get definitely a structured question, essay question, and few MCQs, maybe like 4, 5 MCQs every year. There are some lessons like that under your syllabus. There are some lessons like that. Oscillation waves is one of them, right? Oscillation waves is one of them. You would definitely get a structured question from oscillation waves. You get one structured question from oscillation waves. Definitely essay question will be there. 4 to 5 MCQs every year. 4 to 5 MCQs every year. Apart from oscillation waves, what are the other lessons like that? Can one of you tell me what are the other lessons like that? You definitely get essay question, definitely get a structured question like that. Can you tell me that? Any one of you? Any volunteer? You can use the chat box, because I'm looking at the chat box and teach you all. So you can comment, no problem. And if you have any issue, yes, 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 you are correct. One of them is heat again. Heat, oscillation waves. How about the other students? There are another unit like that. Any one of you? Any guesses? Definitely you would get. Definitely you would get. Any one of you? Yes, exactly. Current electricity in Sara. Right. Okay. I'm sorry if I'm not pronouncing your name properly. Sometimes with the distance, sometimes I can't exactly read your name, but I think if there is any issue, please pardon me. Right. So there are 3 lessons like that: oscillation waves, thermal physics, heat. Other one is the current electricity. So you would get definitely structured and essay. The mechanics you can't tell like that. Mechanics you can't tell like that, Lama. You can't say definitely you get essay question from there. Structured question from there. So that is why I'm telling you this is so important topic for you all. So try to get the maximum of it. Try to get the maximum of it. Right. So in my lesson, in my convenience, for my convenience, I'll be split this unit number 3, which is the oscillation waves, into 6 main topics, 6 main subtopics, right? 6 main subtopics. And oscillation waves is very important topic, as I told you, for your exam, as well as it is so important for your life, right? For your life. The things that you see, that is because of what? A type of wave. That is because of wave you have of the you see the things because of the light waves. You see the things because of the light waves. You perceive the sound because of what? Sound waves. Because of sound waves. You perceive the things, you perceive the sound because of the sound waves. So mainly you can see, that is because of the light waves. You can hear, that is because of the sound waves. There are like 2 different types of waves, I must say. The sound wave itself is a mechanical wave, Light wave itself is a electromagnetic wave, right? Electromagnetic wave. There are mainly two classifications for you all when it comes to waves. There are mainly two types of classification. One is mechanical waves, like sound waves, the waves which is on a ripple tank, which is on the water surface. So those are belongs to like waves along the strings. Those are belongs to the mechanical waves. A medium is required to propagate, right? Let's say you and me, you can hear the things. That is because there is a like there should be a medium in between you and me. If there's a vacuum, you can't hear the things. You can't hear the things. There must be a medium to propagate. The sound waves need a medium to propagate. But when I take the light waves, there is no medium. I mean, there is no requirement for a medium to propagate. Light waves, we don't want a medium to propagate. You can even hear me if you can even see me if there's a vacuum in between you and me. You can, when I'm speaking, you can see my face and the expression, but you can't hear it if there's a vacuum in between you and me. So mainly there are two classifications, as I told you. One is a mechanical wave, other one is electromagnetic waves. Mechanical waves, electromagnetic waves. The basic difference between those two, mechanical waves need a medium to propagate. It need a medium to propagate. Electromagnetic waves, we don't want a medium to propagate. That's the basic difference, remember. There's another type of wave. If you all are reading text, I mean, if you all are reading like the day-to-day things, mainly the scientific oriented things, you may heard that one. Can one of you tell me that? What is that? Anyone else? Any one of you? Any one of you? What are the other type of wave? So you are feel free to question me anytime you have anything. Please use the chat box. I am looking at the chat box and teach you all. If you have anything, you can feel free to question us anytime. But මොනවාරි question එකක් තියෙනවා නම් අහන්න මම ඒකට answer එක දෙන්නම්. Right. What is the other type of wave? Any one of you? Have you heard something called the gravitational wave? I don't think. So if you have heard something like that, you are the one like who are like reading the things. There's something called the gravitational wave, which is mainly discussed by Einstein. The Einstein is a scientist that he have done many experiments. He had done many experiments, but he has a brain to think lot of things. He imagines certain things and explain. You can't even imagine the capacity that he has. So what he told in a paper, there is something called the gravitational wave that originate. That is because of like when two black holes collide to each other, the energy dissipates. This energy dissipates as a gravitational wave. What he told is that when two black holes collide each other, the energy propagates as a gravitational wave. After 200 years later, one of the universities in America confirmed that there is something called the gravitational wave exists. Another university in Israel, they confirmed that there is something called the gravitational wave exists. But the problem here is, it is so difficult for us to do experiment on the gravitational wave. Why is the reason? So definitely there must be a collision between the two black holes to originate that kind of wave. So we don't know when it is happening, right? It may be another 3,000 years later that could happen. Remember that there is something called the gravitational wave, which is not in your syllabus. Even most of the teachers, even most of the students don't know about that. But remember, there's something called the gravitational wave. So if you are studying in a university, like maybe like the university in England or somewhere else, they would teach you something like gravitational wave. In that day, you would remember this. There's something called the gravitational wave that is originated because of the collision between the two black holes. Always remember the energy propagate like a wave. The main source of energy propagation is a wave. The wave is a medium. The wave is a method to propagate the energy from one point to another point. From one point to another point. You know that the energy of the sun propagate from that distance to the earth like electromagnetic wave. We get the energy from the sun through the electromagnetic waves. We get it from the electromagnetic waves. So there must be waves definitely to transfer the energy from one point to the another point. So with that, actually that's what we call the preamble. පූර්විකාව කියලා කියන්නේ වාට ඒ වගේ අයිඩියා එකක් තියෙනවා. සබ්ජෙක්ට් එකක එකපාර ඉගෙන ගන්න එක නෙමෙයි කරන්න ඕනේ. මේ පොඩි අයිඩියා එකක් යන්න ඔළුවේ නැක්කෙන්න ඕනේ. මෙන්න මේවා තමයි මේකේ තියෙන කන්ටෙන්ට් එක කියලා. It's called preamble. In English we call it preamble. Sinhala we call it purvika. If you look at the books, normally it's given like purvika or something. So as I told you, I'll be discussing one by one what is mechanical wave, what is electromagnetic waves. Nothing to worry, but I'm just telling you there are like 3 types with the gravitational waves, but we are not discussing it because it's not in the syllabus. You are clear up to that level? Okay, right? Okay. Now we'll come to our topic. It is unit number 3, oscillation waves. As I told you, I'll be split that topic into 6 main topics. Starting from simple harmonic motion. It is the first topic. Simple harmonic motion. Number 2, the types of waves and their properties. Types of waves and their properties. Number 3, the Doppler effect. Doppler effect. Number 4, stationary waves in different mediums. Stationary waves in different mediums. Number 5, sound energy. Sound energy. Number 6 is optics. Optics. Right? In this case, you may sometimes use spectacles. You may use spectacles with a certain sight. But most of the students, they know what is the sight it has. What is the defect it has? What is the defect they have? We call short sight, long sight, right? When you get older, you can't see the close one, you can't see the distance one, distance objects. You may have seen that your parents or maybe your grandfather or the grandmother uses spectacles. So when they are looking at the distance object, they look like that. When they are look through the, when they are trying to look at the close object, they look like that. So there are 2 lenses. There are 2 lenses in the same frame, same location. One is for to look at the distance object. One lens is to look at the close object. Within the same box, the 2 lenses are embedded, right? Embedded. So like that, you will discuss those things under this topic. One, there are not only that, under the optic, you have the telescope and the microscope. The telescope is to visualize or observe the very distant object. Microscopes are to observe the very close objects. You will realize that when the time comes. When the time comes. Okay, just write a topic, unit number 3. Unit number 3, oscillation and waves. Oscillation and waves. Oscillation and waves. Oscillation and waves. Right. Okay. Right under that. This section is mainly this section is mainly this section is mainly divided into six subtopics. Six subtopics. Six subtopics. Six subtopics. Number one, simple harmonic motion. Simple harmonic motion. So within bracket write S dot H dot N. So when I'm giving you the when I'm asking you to write, you use this symbol like SHM, simple harmonic motion. That will save the time. Simple harmonic motion. Within bracket write simple harmonic motion. SHM. Number two, wave motion, comma, their properties, wave motion, comma, their properties, and their use. Number three, Doppler effect. Number three, Doppler effect. Doppler effect. Doppler effect. Number four, stationary waves. Stationary waves. Stationary waves in different mediums. Stationary waves in different medium. Yes, they are the you can no issue. You can join again, no issue with that. Only thing is you miss a certain part. That's all. Right. Stationary waves in different mediums. Number five, sound energy. Sound energy. Number six, optics. Number six, optics. Number six, optics. Optics. Right. Okay, we will move on to the first topic today. Write a topic, oscillation and waves number one. Please complete like that. Don't skip the things. Oscillation waves number one. Simple harmonic motion. Simple harmonic motion. Oscillation waves number one. Simple harmonic motion. Right. Okay. So if you have anything, I'm repeating again. If you have anything, please ask questions. So I'm here to teach you. You are here to learn. That's only link between us. If you have anything, please ask. Feel free to feel free to question us anytime. If you have anything, please ask, because since it's a live class, take the benefit of it. right? Take the benefit of it, right? Okay. So, Lamai, there are mainly three types of motion in the world, right? Loke Chalita Moolikava Tunak තියෙනවා. There are mainly three types of motion in the world. One is called linear motion. Sometimes we call it translational motion, a motion along a straight line. Motion along a straight line, we call it linear motion. Sometimes some textbook they use translational motion. Number two is called angular motion, a motion with an angle. A vehicle bend, take a bend like that, angular motion. Number three, what is that? Any one of you? What is number three? Actually, tenula, I think, right? You are a boy. Tenula, I think tenula. Rotational motion is not that. Actually, rotational motion is a subset of what I'm trying to discuss here. After that, angular motion and the circular motion, angular motion, rotational motion, all are belong to one category. There is another one. I will come to that. Any one of you? Any guesses? Okay. Tenula, right? Sorry. Any one of you? That's what we call periodic motion. Periodic motion, a motion repeated with the time. It's called periodic motion. A motion repeated with the time. Periodic motion. There are mainly three types of motion in the world. One is the linear motion. So other one is the angular motion. Third one is called the periodic motion. The same motion repeated over time, right? Same motion repeated over time. That's what we call periodic motion. The same motion repeated over time. For example, let's say you have the sun. You may have several planets around it. The planets are moving around the planet, the planets are moving around the sun. Most of them are moving an elliptical track, exact, not circular. So the same motion repeat over time. That's what we call periodic motion. Same motion repeated over time. It's called periodic motion. So linear motion you learn under the mechanics. Angular motion, rotational motion, which is known as circular motion again. There is two different things. When I explain it, I explain it properly when I did it. Circular motion is what? Circular motion means you have a center here, the object move in a circle. Object move in a circle. What is rotational motion? You have axis along your body. Let's say I'm having a rotational motion. I'll be rotating like that. This is what we call rotational motion. I rotate about my own axis. That's what we call rotational motion. So we discuss those two under the mechanics using rotational motion and circular motion concepts. The third one is the periodic motion, which will be start today, right? Under the oscillation wave. So we discuss all the three types of motion in the world under your syllabus, not in detail, but up to a certain level, we are discussing it, right? So if you all are going to engineering faculty, maybe you learn that under the first year syllabus, you have that certain points, right? Try the topic periodic motion. Write a subtopic periodic motion. A motion that repeat itself. 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 A motion that repeat itself at equal intervals of time. A motion that repeat itself at equal intervals of time. Equal of time is called periodic motion. Is called periodic motion. A classic example, a classic example, a classic example of periodic motion is classic example of periodic motion is the motion of all planets, motion of all planets around the sun, around the sun. Planets around the sun. Motion of all the planets around the sun. It's called periodic motion. A motion repeated with the equal times interval. Right. Okay. Let me to explain another few important points with you. Let me to take a pendulum. Let me to take a pendulum like this. The pendulum is nothing else. It has a spherical object which is connected to a string. Spherical object which is connected to a string. We call this spherical object as a bob, B-O-B, B-O-B, bob. So are there any students who can't understand Sinhala? I'm not teaching in Sinhala. I must tell you that. I'm just asking you whether to have an idea at all. I'm not teaching in Sinhala. I'm just asking you, are there any students who can't understand Sinhala? Are there any students who can't understand Sinhala? Yes, yes, I explained that. Don't worry. Are there any students who can't understand Sinhala? Sinhala තේරෙන්නේ නැති කවුරු ඉන්නවද? Right. Okay. No. Right. Okay. The pendulum is something like that. It has a string. Let's say you are in a string like that. You connect an object at this point. So this is simply pendulum. Haven't you seen that in a wall clock sometimes the bobs are like oscillating like we call it oscillating. It has a kind of periodic motion. A motion repeat with the time. Same motion repeat with the time. It's called periodic motion. Right. So this is a pendulum. Right. This is a pendulum. If I pull it and release, you know that a motion reach to a point like that, turn back, it comes along the same path, but I just draw in with a small separation and again come to this point. Come to there, turn back, come to here, because once it reaches to this location, let's say I take that and release it, it can't stop here. It will definitely come to this point, again turn back, again turn back. So that's what we call a kind of periodic motion. Motion repeat with the time. A motion repeat with the time. Another example. You have a spring like that. You pull it and release it. What kind of a motion is that? It comes to this point, turn back, come to the top, turn back and come to this location again. Like it having the same motion again and again, again and again. That's what we call periodic motion. A motion repeat with the time. There is something called restoring motion. Restoring motion. What is the special thing here? In a restoring motion, it is definitely a periodic motion. motion repeat with the time. The only thing is it oscillate about the mean point. If I take this location, if I take this location, it oscillate about this point now. It oscillate about this location. If I take this point, it oscillate about this point. So if an object oscillate, if an object has a motion about the mean point, then it is called restoring motion. A motion repeat with the time, it's a periodic motion again. But out of the periodic motion, if the motion repeat about the mean point, then it is called restoring force, restoring motion. Restoring motion. It's a subset of periodic motion. If you have a periodic motion like that, out of that a small section is goes to the say restoring motion. Restoring motion. Even a swing, swing the swing also has the restoring motion. A motion repeat with the mean about a mean point. If I take this as a mean point, swing, like you know that now. The new year is coming now. This you also can swing like that. So it's rotate about mean point. It's called restoring motion. Just write a topic, restoring, oscillatory motion. Better write like that. Oscillatory motion. Oscillatory, restoring motion, the same thing. Oscillatory motion. Oscillatory motion. OSCILLIATORY. Oscillatory motion. Oscillatory motion. Oscillatory motion. Right under that. This refers to the to and fro. To and fro. To and fro. So it's like to and fro. To and fro. To and fro. To and fro motion of an object. To and fro motion of an object. To and fro motion of an object. To and fro motion of an object around a mean position. Around a mean position. A common example. A common example. A common example. A common example is the oscillation of a simple pendulum. Is the oscillation of a simple pendulum. Is the oscillation of a simple pendulum. Or a swing. Or a swing. Or a swing. Or a swing. Right. So you can draw these two. You can draw these two. This is called helical spring. Helical spring. We call it helical spring. The length of the spring is L. This is object, spherical object. Just draw those two. Once done, tell me, right? Because I can't see you, ne? Once done, tell me. While andale ivaroda pass potta mata kiyanna because I can't see you. Better if you can tell me that. Right. Okay. Write a topic. Restoring force. Restoring force. Restoring. Restoring force. Right. Let me explain that. So let's say there's an object on top of a smooth surface. You have an object on top of a smooth surface, right? Which is connected to a spring like this. This object is connected to a spring and it is kept on a smooth surface like that. Okay. So what I'm going to do there, I'll give a small force on it and pull it up to a certain level. Now it reached to this location from the mean point. Let me draw the mean point. This is your mean point. About this, from there is a certain distance. Let's say it is capital A. Capital A. I apply certain force on it. Let's say the applied force is F1. Now the system is in equilibrium. How the system is in equilibrium? You know that from the spring, the equal and opposite force is now apply on it. Let me to take that as F1. The equal and opposite force is apply on it. That's how it is in equilibrium. Now, once I release it, once the applied force is released, I pull it and release it. What will happen? It will start with the zero velocity, zero speed, and increasing velocity, it comes to this point. We know that it is now come to the original length, but it can't stop. What will happen? It pass this point and come to this other side. Now the spring get compressed. Now the spring get compressed. So once the spring is compressed, there is opposing force for that object from the spring. From the spring. Look at here. Since there is no energy dissipation, it will definitely take the same distance as A from there. But remember, you can understand there is a force opposite to that, which is the same mass F1. So like that, if there is no energy dissipation, it may have the same motion, which is repeated with the time. The same motion repeated with the time, which is known as the oscillatory motion. Now I'm going to do what? I will take an intermediate point. I will take in an intermediate point, a point like this. A point like this while it is moving. I will take an intermediate point along the same track. Along the same track, we will take the intermediate point. Now the object is here. From the mean position, this displacement is x. This displacement is x. Right? That displacement is x. Definitely from the spring, there is a force on it. Let me to take that force as F. The mass of the object is m. The mass of the object is m here. So this kind of force is known as restoring force, because they try to take it back. They try to bring it back. This is called restoring force. Here the F1, F all are called restoring force. We call them restoring force. Right? It is very clear from the mechanics, you know it. The force that apply is proportional to minus x. So you might wonder why it become minus x. If I consider the vector concept, force is opposite of the displacement. Displacement is measured always from the mean point. From the mean point, you are measuring the displacement. So you have positive x, you have negative f then. F and x are two opposite in direction. That's why I'm taking as minus x. Right? Here, you can cancel the proportional sign by putting a constant here. F equal minus kx is there then. Let me to apply F equal ma for this, for the object. For simple m, F equal ma towards that direction. F equal minus kx equal ma, a equal minus k over m into x. K is a spring constant. You may learn that. You know that actually from the mechanics, you know it. K is called the spring constant, or sometimes we call it force constant. M is the mass of an object. For a given system like that, this whole term is a constant. Are you clear up to that level? I have something to tell you beyond that. Are you clear up to that level? You have anything to ask? Anyone else? There is one question from one of the students. So what is mean by energy dissipation? So let's say this surface is rough. It's not smooth. In that case, when the object is moving along the rough surface, due to the friction, that object needs to do work, so the energy dissipation takes place. That's the reason. Understood? Okay, right? So everyone is okay with that, or so far it's okay? Right. So here this is called scent of vibration. Mean the method vibrate. It's called center of vibration. We can call it mean position. About the mean position, object is oscillating. Object has oscillatory motion about the mean point. Right. I hope you have written the topic restoring force. Just write under that. Consider where a spiral spring is placed. Consider where a spiral spring. Consider where a spiral spring is placed on a smooth table. Where a spiral spring is placed on a smooth table. Smooth table. Smooth table. With one end connect. With one end connect. With one end connect to a fixed point. With one end connect to a fixed point. One end connect to a fixed point, and the other end, and the other end, and the other end at the other end attached to an object, attached to an object, attached to an object of mass m, of mass m. Mass m. Leave a line and write. Leave a line and write. If the object is pulled slightly, if the object is pulled slightly, if the object is pulled slightly, if the object is pulled slightly to the right, to the right, to the right, to the right, by a force F1, by a force F1, by a force F1, by a force F1, as illustrated, as illustrated, as illustrated, as illustrated in the figure, in the figure, an equal and opposite, an equal and opposite force, equal and opposite force, an equal and opposite force is need, is need, is need to maintain, to maintain, to maintain, to maintain the equilibrium, to maintain the equilibrium, maintain the equilibrium. This opposing force, this opposing force, this opposing force is known as, this opposing force is known as restoring force, restoring force. This opposing force is known as restoring force, restoring force. Restoring force. Right. Next point. Okay. Next point. Once the applied force is removed, once the applied force is removed, you have removed applied force, then it is moving this way. Once the applied force is removed, once the applied force is removed, the object return towards the object return towards the object return towards the mean position, towards the mean position, towards the mean position due to the restoring force, due to the restoring force, restoring force, restoring force. Right. Shall we draw those four figures here? If proportional x means this is come from the Hooke's law. I think you know about the Hooke's law. Under the mechanics we have done it. From the Hooke's law you get it. From the Hooke's law. Hooke's law. Complete these four figures and tell me, right? Once done, tell me. Don't do anything beyond that. Once done, tell me. Right. Okay. Okay. Right under that, if the displacement is x, if the displacement is x from the mean position, if the displacement is x from the mean position, then according to the Hooke's law, f proportional minus x, f equal minus kx, f equal minus kx. Right. Put a stand right. Put a stand right. The minus sign in the equation, minus sign in the equation, minus sign in the equation minus sign in the equation indicates that the direction of the displacement and the restoring force, direction of the displacement and the restoring force are opposite. Right. Okay. Now, I think you have come to a certain level, certain point. There is something called simple harmonic motion. We are going to discuss it now. So you have learned certain part up to this level. What is restoring force? What is the periodic motion? You have learning. So now it is time for us to learn what is simple harmonic motion. The simple harmonic motion can be explained along this section. What is that? If it is a simple harmonic motion, it should be definitely oscillatory motion. It should be definitely oscillatory motion. A motion that repeat about the mean point. Right? About a mean point. A motion that repeat about a mean point. That's the first requirement. Second requirement, it should be along the straight line. That repetition, that motion need to be along the straight line. It should be along the straight line definitely. Should be along the straight line. And the third point, the acceleration or the force. The force is directly proportional to the displacement. Force is directly proportional to the displacement, and they are opposite. Why? This is the restoring force, this is the displacement, they are opposite. But anyway, they are directly proportional in terms of magnitude. In terms of magnitude, they are directly proportional. So there are few things that you need to understand. One is it should be a oscillatory motion. The second one, it should move in a straight line. Third point, if there is a force, that should be proportional to the displacement and they are opposite in direction. If such motion exists, then it is called simple harmonic motion. As I told you, you know that you have a periodic motion. Out of that, I told you you have a section called periodic motion. You have a section called oscillatory motion. Out of that, this is the subset of that. It is the simple harmonic motion. Oscillatory motion එක කොටසක් තමයි simple harmonic motion කියලා ඉන්නේ. එකම දේ ඒක straight line එකක තමයි යන්නේ. Can I take the swing then? Can I take the swing then? Can I take the swing? Can I use the swing for the... Can I use the swing? No, I can't use the swing. The pendulum also, with the certain condition you can apply. If you have an angle which displays is very small, then it becomes a straight line approximate. You can approximate that into a simple pendulum. You can approximate if that is the displacement is so small. If it is very big, it is again like a swing. You can't take that. So if it is a simple harmonic motion, it should be along a straight line. Definitely strong along a straight line. There are some requirement as well. The F proportional x means acceleration also proportional to x. F equal ma, mass constant. F proportional a. F proportional x means F proportional x means a proportional x. But they are again in the opposite direction. Right. Write the topic. Definition of simple harmonic motion. 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 Right under that. Simple harmonic motion. Simple harmonic motion. Simple harmonic motion occurs. Simple harmonic motion occurs. Simple harmonic motion occurs when the acceleration of a moving body, simple harmonic SHM, occurs when the acceleration of a moving object, when the acceleration of a moving object is always direct towards an equilibrium point. An equilibrium point. An equilibrium point. An equilibrium point. Its magnitude is always directly proportional to the displacement. Directly proportional to the displacement. Directly proportional to the displacement from the mean point, or from the equilibrium point, or mean point, from the mean point. Leave a line and write. Simple harmonic motion, SHM. Simple harmonic motion. Simple harmonic motion is a type of oscillatory motion. Oscillatory motion is a type of oscillatory motion. Oscillatory motion. But not all oscillatory motions are, motions are simple harmonic. Simple harmonic. Simple harmonic. simple harmonic. Right. Write a subtopic, characteristic of simple harmonic motion. So, Lamai, when will be your term test? There are some requests from some of the students. Can I know your term test? When will be your term test? Can I know your term test, please? When will be your term test? Okay, you are a private candidate, no problem. How about the other students? April 21st. So it means you March 26th. So that means your one is now going on. Aisha, I think your one is going on. Eh? So there are several students request me to they won't be able to join the today's class because of the term test they have. Right. So different people, different tastes. Eh? Okay. Right. But anyway, I don't have much idea to do lot of things today because most of the students are having term tests in the coming days. Today is a Sunday, no? From tomorrow onwards, they have the term tests. Right. Anyway, just find a topic: characteristics of simple harmonic motion. Characteristics of simple harmonic motion. Abhigyan and simple harmonic motion. So the characteristics, right? The first one is it should be a periodic motion. That's the one characteristic. A motion repeat with the time, so it's a periodic motion. Number one, the motion is periodic. The motion is periodic. The motion is periodic. Number two, the acceleration is proportional to the displacement, right? Number two, the acceleration of the moving object. The acceleration of the moving object. Acceleration of the moving object. The acceleration of the moving object is directly proportional to the displacement to the displacement directly proportional to the displacement from the mean position from the mean position from the mean position. Number three, the acceleration is always direct. The acceleration is always direct towards the mean position towards the mean position. Towards the mean position. Right. Let me to consider this instant. This is your mean position. From the mean position, it has a displacement of x. You have a restoring force F by the spring. By the spring, you have the restoring force F. This is your mean position. The mass of the object is m. Okay. So you can apply F equal ma for that object. For simple m, F equal ma. F equal, we know that F is equal to minus kx from the previous discussion. Kx equal ma. A equal minus k over m into x. K is a constant for a spring. What is k here? Spring constant. M is the mass of the object. K is a constant for a spring and M is a constant for a given system. So that means for this system, this is a constant. This is a constant. For the time being, let me to take that constant as omega square. Omega square K over M. I know that you don't know what is omega, but I will show you later what is omega. For the time being, just take omega. Omega is the same meaning we have angular velocity. We call it angular frequency. Angular velocity or angular frequency. A is equal to minus omega squared into x. Minus omega squared into x. So this is called characteristic curve, characteristic equation for a simple harmonic motion. If somebody want to show that this is simple harmonic motion, he has to develop equation up to this level. If somebody want to show that we have a simple harmonic motion, he has to definitely show that this kind of equations exist. What is that? Acceleration minus value constant into displacement. If we show it like this, definitely that prove this is a simple harmonic motion. So you might wonder why I take that omega squared here. So omega squared is, we can show you what is omega. There's a direct relationship between the simple harmonic motion and circular motion. So there's a direct relationship. We can show it easily with the example. Then no problem, right? Then no problem, right? Anything to ask anyone else here? Number one characteristic motion is periodic. Number one is periodic. ඒක තමයි කිව්වේ. ඒ කියන්නේ periodic කියන එක තමයි පළවෙනි characteristic එක. Periodic. First characteristic is periodic. Okay. Right. Write a note. We'll write a note here. Again draw that and complete up to that. Again draw that and complete up to this. Once done, tell me, okay? ඔයාලා වැදගත්ම දේ class එකට, if you are joining this class, if you are joining this free seminar series, you have to have three things, four things mainly. One is you need to join the class regularly. It's a must. අනිවාර්යෙන්ම regularly class එකට එන්න ඕන. Second point, when I'm teaching, you need to pay attention. So the attention එක ගහ ගන්න. තේරෙන්නේ නැත්නම් අහන්න, because all our live classes, no, you can ask questions. Third point, redo what I do inside the class, not to memorize, but to understand. If you understand the physics only, you can do something at the exam. The fourth thing, if I am asking you homework, you have to do homework and join the class. If you follow those four steps, nothing to worry. You get full mark, nothing to worry, right? There's nothing to worry. K is the spring constant. Spring constant. Tenula, are you like 2027 student or 2028 student? All right, okay. So which sections you are doing in your class? I mean, the K has to be developed from the under the Newton's laws. You may learn that. Yes. Which sections you are doing Tenula in your classes? So you need 3. Okay. Okay, no problem. The spring constant is something that you learn under the mechanics part. It's like it's available under the Newton's laws. That's I'm asking you. Right? Have you completed up to this level? Every one of you completed? Done, eh? Right. Okay. Put a stand right. Put a stand right. The above equation is known as the above equation is known as the above equation is known as characteristic equation. The above equation is known as characteristic equation of simple harmonic motion. Characteristic equation of simple harmonic motion. Characteristic equation of simple harmonic motion. In here, omega is known as angular frequency within bracket angular velocity angular velocity angular velocity. Right. In the previous discussion, you remember uh, the previous figure. I can easily show you. Right. There is some term called amplitude. 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 Within bracket capital A. So amplitude means the maximum displacement from the mean point. It's called the maximum displacement from the mean point. Here it is amplitude. It is amplitude. It's called the maximum displacement from the mean point. It's called amplitude. Write the subtopic amplitude. Amplitude, capital A. The maximum displacement from the mean position. Maximum displacement from the mean position. Maximum displacement from the mean position. Maximum displacement from the mean position is known as amplitude. Is known as amplitude. It's known as amplitude. I will explain, right? Right. Okay. Pay your attention to this. What I'm going to do here, I'm trying to explain you all the direct relationship between the simple harmonic motion and the circular motion. I told you, there's a relationship between the simple harmonic motion and the circular motion. I'm going to tell you. Right. So let me to take an object which is taken along the vertical circular motion. It is not a big thing. You have an object connected to this point. You are taking a vertical circle like that. You are taking a vertical circle like that, right? This is object. So here you have a horizontal light beam. While I'm rotating in a vertical circle like that, a horizontal light beam is projected. When the horizontal light beam is projected, what is the special thing that you can see? Let's say this is capital A. I will take that as capital A. This is capital A. The length of the, radius of that is capital A. This is a certain object. The shadow of that object, think about the shadow of that object with the different positions. Let's think about that. Different positions, okay? I'll start with this point. Let me to explain that. Let's say Let's say at t equals 0, this particular object is here. T equals 0, the object is here. If that is t equals 0, the shadow of that is here. This is the shadow. When this object reached to this point, the shadow of that would reach to here. When this object reaches the topmost point, the shadow of that is here. Travel along this line, come to the highest point, now moving down. When this object reaches to point like this, the shadow of that is here. When it is here, the shadow of that object is here. When it is here, the shadow of that is here. The shadow of that is here. So what is happening? It's come to the top, turn back and reach to this point. Goes up, goes down, down. Again come to this point. Again come to here. Again come to the mean point. It's like keep on rotating. It having what kind of a motion is this? What is this motion? What is that motion? What you call it? What is that motion? When you are having a circular motion like this, the shadow of this object perform what? It perform what? It performs simple harmonic motion, isn't it? This is a white screen. It's a white screen. White screen. This is a shadow. It performs simple harmonic motion. I mean, shadow of the object performs simple harmonic motion, isn't it? Can you understand that, every one of you? How about the other students? You all agree with that? When this perform vertical circular motion, I have kept a screen, white screen. Mama metana vertical circle එකක මේක ගෙනියනකොට මෙහා පැත්තෙන් light beam එකක් ඒකට focus කරාම මේක object එකේ shadow එක screen එකේ travel කරනවා simple harmonic motion එකක්. ඕක තමයි මෙතනදී වෙන්නේ. ඒකට තේරෙන්න ඕන when it is focused, you have the simple harmonic motion. When this object travels from here and complete one circle, this object travel along to this point, turn back and come to there, again turn back. So when it's complete one circle, this complete one cycle. We call it one cycle. It's complete one cycle then. It's complete one cycle. If I know the period of that, let's say the angular velocity of that is omega. Angular velocity of that is omega. Capital T is the period. Period means what? The total time that it takes to complete one circle. It's called the period. Capital T must be equal to 2 pi over omega. That means the total time to take one circle. It is the same time for that one. So that means if I know the relationship between, I can simply tell you that the time duration to complete one cycle is exactly equal to the total time to complete one circle. That's the beauty of this section. There's a direct relationship between those two. Let's say within one second, if number of circles travel, if number of rotations go, if number of circles goes, frequency, number of circles traveled during 1 second. In the same period, same 1 second, it takes the same number of frequency, cycle frequency. Mea what if amount එකක් යනකොට මෙයා cycles F ප්‍රමාණයක් යනවා. Same frequency as this one. So you have to understand there is a simple harmonic motion for every circular motion. For every simple harmonic motion, that means there's a corresponding circular motion. There's an interrelation between those two. So what I try to emphasize, the relationship between those two. There's a relationship between circular motion and simple harmonic motion. Simple harmonic motion එකේ period එකයි circular motion එකේ period එකයි එකමයි. Circular motion එකේ frequency එකයි simple harmonic motion එකේ frequency එකයි එකමයි. ඒතර කෙනෙක්ට මේක හිතන්න අමාරුයි. හැබැයි circular motion එකත් එක්ක හැමෝම තේරෙනවා. ඒතර capital T equal 2pi omega for the period. ඒක මේකටත් අයිති. If that is the frequency, it is omega over 2 phi. If I know the frequency which is corresponding to this circular motion, I can say that within that it has the same frequency. If I know the period, let's say it takes 3 seconds to complete one cycle, this takes 3 seconds to complete one cycle. Within 1 second, it takes 50 circles like that. Within 1 second, it takes 50 cycles like that. So there's an interrelationship between those two, right? This is the shadow of the object. Shadow of the object. Right, shadow of the object. Right, complete that, just write under that, the write topic. The relation between simple harmonic motion, the relation between simple harmonic motion and circular motion. Circular motion. Right, I want you to draw this horizontal light beam. Horizontal light beam. Once complete, tell me, okay? So the student who are in my class, check whether you all received this tutorial, this one. This is the full practical tutorial under the optics. And apart from that, have you all received this, the image document? So I have sent you this one also. The student who are in my class, check whether you receive it. If not, contact Chamara. Done, finished? Okay, write in point form, okay? As in the above figure, 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 object is connect to a string, object is connect to a string, object is connect to a string, and rotate in a vertical, and rotate in a vertical, vertical circular track, vertical circular track, vertical circular track with uniform angular velocity, with uniform angular velocity, with uniform angular velocity. A horizontal parallel light beam, a horizontal parallel light beam is project, a horizontal parallel light beam is project to the system, to the system so that the shadow, so that the shadow of the object, so that the shadow of the object project on the white screen, project on the white screen. It could be observed, it could be observed that the shadow, that the shadow of the object, shadow of the object on the screen, on the screen, on the screen, performing, performing, performing simple harmonic motion, performing simple harmonic motion. Performing simple harmonic motion. Next point. The period of the circular motion, the period of the circular motion, the period of the circular motion the period of the circular motion is exactly equal is exactly equal is exactly equal is exactly equal to the period of the shadow to the period of the shadow which perform SHM, which perform simple harmonic motion SHM. Then it is very clear. Then it is very clear. We can find. Then it is very clear. We can find circular motion, circular motion, which is corresponding to, which is corresponding to, which is corresponding to simple harmonic motion, which is corresponding to simple harmonic motion. Write the topic, the period, capital T, capital T, the period, simply period. Just write under that period, capital T. The time duration for a complete oscillation. The time duration for a complete oscillation. Time duration for a complete oscillation. Time duration for a complete oscillation is called the period. Is called the period. Is called the period. If the period of the simple harmonic motion, if the period of the simple harmonic motion, if the period of the simple harmonic motion is capital T, T equal to 5 over omega. T equal to 5 over omega. Write the topic frequency. 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 Right under that. Number of oscillations. Number of oscillations during a second. Number of oscillation during a second. Number of oscillation during a second. Number of oscillation during a second is called the frequency. Is called the frequency. F equal, as you remember, under the circular motion, it is 1 over T. F equal to 5 over omega. So F equal omega over 2 5. Omega over 2 5. Right. You have anything to ask regarding this topic up to the point I have completed so far? Oscillation means this. You're oscillating, right? Oscillatory motion means, as I told you, like the motion that repeated about a mean point. That's what we call oscillatory motion. Oscillation means that. Anything to ask any one of you? Right. Look at here. One more thing I will tell you and stop. Look at here. And there's a one thing to tell you regarding this one also. I think it's better to discuss this part with the student. Uh, right. Slavai, this is my website. Most of you might familiar with this website. The students like who are not familiar with this, I'm just telling you some important point regarding this. The once the class is over, I'll be uploading this recording to my website, so you get the unlimited times to watch these recordings, unlimited times to get the recording. But there are few things that you need to remember when you are using the website. Even I'm just telling you this, the students with my class also, they are using wait, you have to use the website properly to get the best benefit of it. First you need to, so once you enter your phone number, you get a OTP. You get the OTP like this and enter it. So once you confirm, you are getting to fill this data. Please fill this data. Let's say you are like fill this data. So then go to the classes. There are few things I need to tell you. That's why I'm gonna take it. There are some. Let's say you have selected my 2026 reverse class. When you are like watching these recordings, let's say that the surface tension which I did for the 2026 class, When you are using this, there are a few things that you need to remember always. Normally, you get 10 hours to watch this record. So normally my class is 3.5 hours, 4 hours. So here normally you get 3 times to watch the recording, right? 3 times to watch the recording. Once you watch it, let's say you even though it is 3 hour class, you could able to watch it like this much of time, and you need to watch in the tomorrow. You need to watch them in tomorrow class. Sorry, tomorrow free time. So remember to press this button. Then no problem. You get the chance to watch it again. Most of the students are not touch that button, and their 10-hour period is now gone. Otherwise, gone. Remember to use that. So take the advantage of this website. You get the unlimited times of recording to watch it. Right? If you feel that's so difficult, the lesson, so you can watch it again. You can watch it again at the, let's say, at the mid of this, let's say, close to the exam. Again, you can watch it, no problem. But remember, don't give your contact, the contact details or anybody else. Otherwise, it will be locked. It will be locked. So then you need to ask others to unlock it. There is so issue with that. So remember, don't give password any other things to your colleagues. And if you are using dialog connection, it's free of charge. It's free of charge, right? Remember those things when you are using this. So what I wanted to tell you is this. You remember the spring object system, which I explained earlier, right? For that one, we have derived an equation like that. Like that. We have derived an equation like that. It is A equal minus K over M into X. It looks like minus omega squared X time. I need to find the corresponding simple harmonic motion of this corresponding circular motion of this simple harmonic motion. It is this. It is the way that you need to use here. Omega squared equal K over M. Omega then equal K over M. Root K over M. So this is the omega which is corresponding to the simple harmonic motion here. If you want to find the total time to complete one cycle like that, or number of cycles like that, no problem, because you know the omega here. Make a correspond with a circular motion එක ගැන හිතුවොත් ඒ circular motion එකේ angular velocity එක තමයි මෙතනින් ගන්නේ. මේක තමයි. ඒක capital T equal 2 pi over omega නේ. T equal 2 pi K over M. This is the period of this. If I want to find the frequency, that also possible. 1 over T. 1 over 2 pi K over M. It is very simple. Only thing is you need to develop an equation like that and say that it is looks like A equal minus omega squared X, and make omega squared equal to that quantity, then you know everything. That is how you relate the link between those two. So from next week onwards, we'll be discussing and section and complete this lesson. If you don't have anything to ask, we'll wind up the class here. Today we'll wind up. So the next again Sunday, your normal class is on Sunday, right? You don't want to pay any additional amount or any payment for this class. It's free for you all. The month of March is already gone. Now fully April also you free this class. Anything to know? You learned something today? Have you learned something today, the student who were not in my class? I hope you have learned something. So we will meet again on next week. We'll meet again on next week, right? If you have anything, please contact my private number. I think you have my number in the group. 07144777069. This is my contact number. We will send you the soft copies of the print, the tutorial. We are delivering the tutorial to your home. I mean, my class students, my students. Others, we will send you the because we don't have chance to send you a home. But anyway, we'll manage to send you the PDF format, right? Okay, we'll meet again on next week. Good night, everyone of you. Thanks for joining the live class.